Hello, everyone. It's Mrs. C, and I'm coming to you today with a small little screencast on rationals. So, what are rationals? Let's think about it. Rationals. It's funny because we just got through going over radicals, and the word, when you hear radical, sounds like crazy, right? Just it's insane, it's wacky, it's radical. Then you hear the word rational, and you think, I mean, this must be a very, thoughtful topic. It logical, possibly rational, totally rational, not radical. I don't know. It just strikes me as funny. Rationals. Now, really, technically, the word rational is a word you've been dealing with forever, honestly. I mean, well, maybe not forever. That's probably pushing it. But since, say, fourth grade, I would think we've been talking about rationals. So let's go over what we know about rationals, and then let's take a look at what we don't know. Let's say a rational expression, because that's what we're really doing. We're going to simplify rational expressions. So simplifying the rationals. Now you're probably wondering, well, what else could you ask me to do? Well, I could ask you to solve rational expressions, multiply and divide rationals, add, subtract. There's a lot of things I could ask you to do, but for now, just simplify them. So let's take a basic rational expression that you've seen before. 2/6. Now, if I asked you to simplify 2/6, you could probably go off here to the left and say, easy, divide the numerator and the denominator by the same thing. 2 divided by 2 is 1, and 6 divided by 2, that didn't quite work out the way I wanted. 6 divided by 2 would give me 3. And so, no surprise to anybody out there, the rational expression of 2/6 simplifies to 1/3. So just get rid of some of this extra stuff. Then how hard could they really be? Well, first I need you to take a look at what you weren't thinking about when you simplified this. I don't know if you were thinking about it. I don't think you were. If you could break down 2 into, let's say, factors, prime factors would be fine in this case. You would say 2 times 1. And then if you were to break down 6 into its prime factors, what would you give me? 2 times 3. You see, it's this 2 and this 2 that cancel out, because anything above and below, any number that's the same in the numerator and in the denominator would cancel out, because 2 over 2, or 2 divided by 2, is 1. And so this is really what you did here. And you're probably saying, no, that is not what I did. Yeah, it really is. Take a look again. Let me give you one maybe a little bit saucier. Can you simplify 12, I don't know, say 16ths? But first I want you to break it into factors. Now, you don't have to break them into prime factors. That's going all the way through. You could just break them into factors where they have like factors above and below, but just for the sake of argument, let's do it into its primes. A 12 would be 4 and 3, right? And 4 times 3 could be broken into 3. Well, that was supposed to be a 3 times 4 times 3. Because 4, no, I got it. Hang on. I haven't had enough coffee this morning. Try that over again. 4 times 3. 4 can be broken up into 2 times 2 times 3. So there's the prime factorization of 12. And let's go ahead and do prime factorization of 16. Now, 4 times 4, right? We'll go down this way. 4 times 4. And then if you break them up into their primes, it's 2 times 2 times 2 times 2. So out with you, out with you. Okay. Now what's left? There's a 3 on the top. And a 2 times 2 on the bottom. It's 4. Now, it's not magic. This is what you've always done. You said to yourself, 4 goes into that 3 times and 4 goes into that 4 times, and that's a lot faster than breaking them up into their primes. But I think it's helpful to really see what you're doing here. Now, I mentioned you don't have to break it into its primes, so let me pick another one. How about 24 over 60? Now, think to yourself, is there a common factor to 24 and to 60? Let me say a GCF, the greatest common factor of 24 and 60. You may know it off the top of your head or you may not. If you know it off the top of your head, then you factor that out. You factor out the GCF first. And by factor out, I just mean set that off to the side as one of the factors. If you don't know the GCF, then pick any F and go with that. It's okay. Take it down to the primes. That's the longest way to go, but it's not a sin. You will still go to heaven if you make it through to the end of the problem. GCF in this case, I don't know off the top of my head if there's one bigger. I'm thinking 6. I'm thinking 6 goes into 24. I'm thinking 6 goes into 60. Now I need the rest of it. 6 times 4, right, gives me 24. 6 times 10 gives me 60. Now, I know that these cancel out, right? But I'm seeing that 4 and 10 have a common factor. 2, right? I should have broken that 2 and 2, and then I could have broken this into 2 and 5, and there's the 2, and there's the 2. This is going to leave me, in the end, 2 over 5. So what was the GCF that I didn't see off the top of my head? Well, it was whatever canceled out. The 6 and the 2 canceled out in the top, and the 6 and the 2 canceled out in the bottom. That would make 12 the GCF, 6 times 2. Had I thought 12 times 5, I would have gotten there a lot faster. See? 12 times 2. So there go the 12s, just like they went here. The 12s went over here on the right too. They just went slower. This one goes more expeditiously, leaving the 2 and the 5. So you're probably thinking to yourself, Mrs. C, why are we going through basic fraction simplifying? I mean, I know how to do that. Exactly. You know how to do that. That's why I'm going over it, because I want you to use that when you're thinking about this. Okay, that's a rational expression. A rational expression is just pretty much defined in my interpretation as any kind of expression with a numerator and a denominator. And pretty much you could write any number as a quotient of its numerator and denominator, but in this case, I'm going to give you some letters and actually, sorry about this, ask you to try to remember what we did when we learned how to do this, when we learned how to factor. So take a look over here. GCF. Think back to the last couple slides. What times what would give me 2x? Well, technically 2 times x, because I can't do any better than that. Now, what times what would give me 2x minus 4? Factoring a binomial is a little bit trickier than factoring a monomial. We were doing monomials when I gave you the, 24 over 60. Those are monomials. 2x minus 4 has this negative or this subtraction sign in between, making it 2 terms put together. Those have to be factored differently. And it's what I like to refer to as the reverse distribution. So you would have a number out here, parenthesis, and a sign in the middle. So in the case of this one, we ask ourselves, what factor, what GCF, do 2x and 4 both have? Well, they both have a 2. So there's a 2. Now you're thinking, whoa, slow down, Mrs. C. What do you mean they both have a 2? Well, 2 times 1. Let me get my eraser. 2 is 2 times 1, right? And 4 is 4 times 1, which would be 2 times 2 times 1. Okay. So yes, they both have ones. I get that too, but ones, remember, don't change anything. It's this 2 and this 2 that I see that they have in common, and I might be able to utilize. So I pull that 2 out and I say, well, what the heck was left? Well, 2 times what would give me the 2x? And then 2 times what would give me -4, -2. Now, if I went a little too fast for you on this, this is review of prior knowledge. So if I threw you off too much, I want you to go back and do a little practice on just GCF terms like monomials, binomials, especially binomials and trinomials. It would be a good idea to go over that. But for those of you that said, yeah, I got it, I know how to do this, let's move on, here I go. Now I broke this up into, you can put parentheses around all of them. I find that the lack of parentheses confuses people. Find a term in the numerator and the denominator that are the same. And cancel them out, just like we always did. And there they are, the 2 and the 2. So those cancel out, and what does it leave you? It leaves you with an x over x minus 2. And though you may be tempted to cancel this x and this x out, I caution you, don't do it if you want to be right. This minus sign traps the x and the 2 in the denominator together. It binds them. And so there is no canceling the x minus 2 out without another x minus 2 in the numerator. And since there isn't an x minus 2, I can't do it. So the final answer, x over x minus 2. All right, let's try that again. Now I just want to say for a minute, let's say I had a over a plus 3. And you're asking yourself, I still don't get that. Why is it that I can't just cancel out this a and say that the answer is, well, a and a 1, right? A and a 1. You would be saying this was equal to 1 over 1 plus 3, which is 4. Okay, so if let's assign a value to a, just so that we can play that back and see if it really works. Let's say a is equal to 2, pretending that I actually know what a is equal to. I don't remember what color I selected, so I'll just do a. That's not exactly an a plus 3. Now, when we evaluated, we simplified, we got the value of 1/4. So I'm saying let's pretend we actually know that a is equal to 2. Would that give me 1/4? In order for the simplifying method to work, I do have to maintain the same value. So what would this be? This would be 2 over 2 plus 3, which is 5. Now there's a problem. They're not the same. And that is why you can't, because do this. I wish you could. It would be so much easier and save so much time. You can't break into these and just cancel them out because of this plus 3. This plus 3 is changing the value of the denominator, and it goes along with the a. It stays with the a, and everywhere the a goes, the plus 3 goes, unless we can come up with another way to separate them. Okay, let's try another example. Poof! Well, thank you, CUDA software, free worksheets, Algebra 1. Plenty of practice here for us. So let's just take number 7. The directions that you can't see, of course, are simplify. Let me shift this screen a little bit. Or simplify the expression. So let's do a little GCF. Now that should look familiar. I just did that one. Very similar problem. I did not think of this when I did it. So, oh, no, don't do that. Okay. I'm going to factor out. I'm sorry. I'm having a little bit of a problem. 2, leaving me r minus 2. Again, that's the numerator. 2r minus 4 can be factored to 2 times r minus 4. r minus 2. If that is hard for you, I want you to go back and look over finding the GCF or factoring terms using the GCF. Then r minus 2, I can't do anything else with r minus 2. You don't need parentheses around everybody, but if it helps you see who's alike, that's fine. There you go, common factors, r minus 2, canceling out. because they're alike. Numerator and denominator, if you have the same number in the numerator and denominator, they equal 1. They cancel out, making this a 1 and that a 1, because r minus 2 divided by r minus 2 is 1. R minus 2 divided by r minus 2 is 1. 1 over 1 is 1, and 2 times 1 is still 2. So all that final answer would be 2. Let's come over to the right. 45 over 10a minus 10. Well, 45 is 45. 10a minus 10 is 10 times the quantity of a minus 1. So now you ask yourself, well, there's no other a minus 1 anywhere, so that's out. What about the 45 and 10? Can I simplify them? Where over here I couldn't. Why can't I simplify them here or here? Is because they're trapped with that minus sign. And so what I want to do is separate them so that I feel safe when I simplify. Now, later Algebra 1 students and Algebra 2 students do know a fast way to GCF all three at the same time. I call it the all three or nobody rule, but let's just pause that for a minute and not talk about it. Let's just factor whatever common factor 45 and 10 have. How about 5? 5 goes into that twice, and 5 goes into that. Anybody out there with how many times 5 goes into that? Well, 5 goes into 40. How many times? 20. So how about 21? Made me have to think a little bit there. I'm doing a little quick math. I'm at 21. Oh, it's 5. That's didn't. Okay. Okay. I forgot what I was doing. 9. 5 times 9 is 45. Oh, the beauty of screwing up in front of the world. 9 over 2 times a minus 1 is the final answer. That's okay. If you feel confident in yourself, you don't mind a couple little brain burps. 9 over 2 times the quantity of a minus 1 is the simplified form of 45 over 10a minus 10. Again, the answers, by the way, you would definitely want to check me on after that. CUDA software, free worksheets. These are rational, simplifying rational expressions. That's the option. And then all of the answers down at the bottom, which I did not copy. You can go look for those yourself. Oh my, let's get a little space here. Let's try number 9. Clean up the board a little bit. Coming over to number 9, let's have a change of color. Maybe it was the green. Maybe green is not my signature color. How about something fun, like a pretty pink? So x minus 4 is as good as I can do on the numerator. And let's take a GCF out of 3x squared minus 12x. Well, 3 for sure, right? But what about x? They both have an x. The first term has 2 x's times to each other, and the second one has 1. So I can't take out an x squared, but I could take out an x. Now reverse your distribution and say 3x times what would give me 3x squared? It would be an x. And 3x times what would give me a negative 12x? That would be a negative 4. Oh my goodness, don't you love that? X minus 4 on the top and x minus 4 on the bottom. That's going to give me a final answer of 1 over 3x. Final answer. Oh, these are just so much fun. I got to do another one. Let's try 10, because it looks like 10 is the last of its kind. If you take a look at 11 and 12, those are a binomial over a trinomial. And woo, we haven't thought about that yet, have we? So enjoy the easy one of number 10 before we jump into the deeper end of the pool. 15a minus 3, GCF, would be a 3. Leaving me, what? 5a minus 1. Nice. Over 24. Let's find that common factor between 3 and 24. It would be 3. 3 and 3, 1. 3 into 24, 8. See, I do know my multiplication tables. Final answer is 5a minus 1 over 8. Final answer. Hopefully, you're checking me, and I'm not making any mistakes. Right, trinomials, here we come. Well, don't fear. Don't fear the trinomial. you know how to factor a trinomial. We talked about that quite a while ago. It's been a while. You use sum product, right? Now, for those of you that might have happened upon this video and you have no idea what I mean by sum product is a method we use to factor a trinomial that is in this form. The coefficient of the quadratic is a 1, so that's important because you can't use sum product any other way. And then all you have to do is look at the middle term, that's your sum, and the last term is your product. And you're just looking for the two numbers that will give you the sum of the middle and the product of the last. I'm sure if you're watching this video, you've already learned how to factor, and some amazing Algebra 1 teacher has already showed you how to do that, and you're doing awesome. If not, I do have pen casts on sum product. Just look it up. Well, first of all, we have v over 5. That's as good as I'm going to get. Now I come down to my sum product. So what two numbers will give me the sum of a negative 10 and the product of a 25? That would be 5 and 5, right? 5 times 5 is 25. 5 and 5 is 10. Now, signs are important. What would be the sign in front of the 5 to give me a negative 10? They'd be negatives. Negative 5 plus negative 5 is negative 10. And in front, we know we just throw the v's. Now, v on the top, v on the bottom, it's a one-for-one deal. Cross one out, you only get to cross one out. 1 over v minus 5. I know you're thinking to yourself, well, that wasn't so bad. I was expecting something worse. Stop being pessimistic. Everything doesn't have to be difficult. Let's do x plus 6 over x squared plus 5x minus 6. In the top, we have x plus 6. Can't do anything else with that one. And in the bottom, sum product. So what two numbers come together to give you 6 when you multiply and 5 when you add? Well, there's two sets, 6 and 1, and 2 and 3. So 6 times 1 and 2 times 3 will add to give you 5. It's the signs that you got to watch on these. Some of the little factoring sum products can be a little bit sneaky. So, what say ye? Would it be the 6 and the 1 or the 2 and the 3 that will give me a positive 5 sum and a negative 6 product? Well, I'm thinking. I really am thinking. I'm thinking it's going to have to be a positive 6 and a negative 1. So 6 times negative 1 is negative 6, and 6 plus negative 1 is 5. So I put my little 2 parenthesis deal down, throw those x's, don't forget, positive 6, negative 1. And look at that, those cancel out, leaving me the final answer of 1 over x minus 1. So you'll see that as you continue on and factor more, you just use the different methods of factoring that you've learned. So I want to show you another thing here. Let me see. Let's put that up. And there you go. Here are some examples. Are there more? Oh, there are. Nice. See, you don't even have to go to CUDA. I've gone to CUDA for you. These are problems number 13 through 20. Look at number 13. Nice. Enjoy it while it lasts because it's the only one of its kind on that page. The rest of them are a little bit saucy. And by saucy, I just mean you have to actually do the sum product for the numerator and the denominator. You have to work that hard. So I'm just going to do one more. I'm going to leave you to finishing the last sheet. Or did I finish it? I can't remember. Finishing this sheet, checking your answers on CUDA. Again, it's simplifying rational expressions on the free worksheets. And also, you can do more because you know there's always more to do. I'm going to do number 15, and then I'm going to set you off on your own. So, sum product for the numerator and the denominator in this case. So, sum product of 8 and 12. 6 and 2, right? And plus, so plus x plus, again, 6 plus 2 is 8, and 6 times 2 is 12. Down to this next one, sum product. I always do my product first. You probably picked up on that. I'm thinking 18, 9, and 2, but that won't give me 3. How about 6 and 3? Ooh, I like it. 6 and 3, I need a negative 18, so one of them has to be negative. It's going to have to be the little one because I need to have a positive 3x. Again, double check that. 6 minus 3 would give me 3, and 6 times a negative 3 gives me negative 18. Now, anybody cancel out? Sure do. If they don't cancel out, if you do all that work and they don't cancel out, then you go back to the original answer. It means there's nothing else you can do. The expression's simplified. That's awesome, except usually on a page like this, they need to be simplified. They've been set up to have you simplify them. So if you don't see anything that can cancel out, you might want to go back and double check your process because you might have screwed up on some product or your factoring. So the final answer, x plus 2 over x minus 3, final answer. You might be asking yourself, is there any way to check step this? There is. You take your graphing calculator and store a value for x. In this case, say 2. Then you evaluate x squared plus 8x plus 12. You get a value. Then the denominator, x squared plus 3x minus 18. Enter. You get another value. Then you get the value of the fraction, whatever it is. Go back and stow with the stored value you have, and then double check your simplified answer. It'll be shorter, x plus 2 over x minus 3. In the end, my babies, you have to get the same answer, the same value, depending on what value you store. So again, go to CUDA, practice your simplifying rationals. Because you know why? Rationals are beautiful. And I know you can do it. I know you're finding it was way easier than you thought, but you know what? It's easy when somebody's walking you through it. Now you got to go. Walk the walk. Talk the talk yourself. And you know what? I'm going to see you on the flip side.